Okay, we're going to finish up with our videos on arithmetic sequences. We're going to look at the last two I can statements. I can determine the explicit formula for an arithmetic sequence, and I can use the explicit formula to find missing data. Okay, so let's figure out where we are here. Okay, and here we are. All right. This formula is called the explicit formula. The explicit formula for an arithmetic sequence is A sub n equals A sub 1 plus n minus 1 times d. Okay. Now what we got to understand is that A sub n is what we call our nth term. That means any number of term that we want to. And n is going to be the position. Okay, the number of the position of the term. Okay, so now here we go. Next slide. To find the explicit formula, we must first find A sub 1, our first term. We then find D, or our common difference. Then we must plug A sub 1 and D into our explicit formula. And then all we're going to do is we're going to simplify it. Okay, so now let's go ahead and look at an example here. Okay, we're going to write the explicit formula for this arithmetic sequence. Okay, now the first thing is A sub 1 is, A sub 1 is 4. Now since we're going down by 5 to get to negative 1 and then down by 5 to get to negative 6, D is going to be negative 5. Okay, and now all we have to do is we just got to substitute these in. So A sub n equals 4, A sub 1, okay, plus n minus 1, we're just going to keep that n minus 1, times d, which is negative 5. Now, the only thing you could do here is you could actually go for and simplify it, okay, and that means we're going to do the distributive property, okay, so negative 5n plus 5, and bring everything else down. Now the last thing we do is combine like terms. I like putting my variable term first, and there's no other n term, so just bring down negative 5n. And then 4 plus 5 is going to be 9. So I'm going to say that the explicit formula, which is special just to this sequence, is A sub n equals negative 5n plus 9. Now, let's write some more explicit formulas for these sequences, okay? Now, for the first one, A sub 1 is 3. D, or common difference, is 6, because I'm going up by 6 each time. So I got A sub n equals 3 plus n minus 1 times 6. Times 6. Distribute your 6, you get 6n minus 6. Bring down your 3, and your A sub n equals. Now combine like terms. So we're going to have A sub n equals, bring down your variable term first, just what we like, 3 minus 6, which is negative 3. That's the explicit formula for that sequence, okay? Now let's look at another example. Okay. Now here we have A sub 1 equals negative 4. Our common difference, if you can't see what it is real clearly, remember, take A sub 2, which is negative 2.5, minus a negative 4. Okay? And do remember that when you take and subtract a negative, you're going to add the positive. Negative 2.5 plus 4 is going to be a positive 1.5. That's going to be your D, 1.5. So now we're going to have A sub n equals our first term of negative 4 plus n minus 1 times d, which is 1.5. Distribute your 1.5, you get 1.5n minus 1.5. Bring down your plus the negative 4 and your A sub n. And then finally you're left with the A sub n equals, put your 1.5 in first. Negative 4 minus 1.5 is going to be a negative 5.5. Okay. Alright, now, finally, let's do one more example of this, okay? We have now that a sub 1 is 2, and our common difference d is going to be negative 2, since I'm going down by 2 to get to the next term. So now I'm going to have a sub n equals, my first term is 2, plus n minus 1, times my common difference of negative 2. Now distribute your negative 2, you get negative 2n plus 2. Bring everything else down. So your 2, don't have to put the plus since that was negative 2n whenever you multiply negative 2 and n, equals a sub n. Now a sub n equals, bring down your variable term first, negative 2n, and 2 plus 2 is positive 4. There we go. Moving on, let's look at finding a specified term. Okay, so first we're going to find the explicit formula for the sequence, plug the number of the desired term in for n, and then evaluate. Okay, so let's find the 31st term of this sequence described by a sub n equals 3 plus 2n. Now that is your explicit formula after taking and doing the distributive property after you plugged in a sub 1 and d and combining like terms. So if I want to find the 31st term, I want to plug 31 in for n. Okay, so let's do that. Okay, I'm going to have a sub 31 equals 3 plus 2. Now in this case, now I'm going to take and plug that 31 in for n, because it's a sub n, so you have n here, okay? So I have 31 here. Now let's take and simplify this. 2 times 31, because we've got to do the PEMDAS here, okay? So I got 62 plus 3. 3 plus 62 is 65. So our 31st term is going to be 65, okay? Now, here's another example. Let's find the 21st term of an arithmetic sequence with a sub 1 equals 4 and d equals 3. So here's our general explicit formula for any arithmetic sequence. Plugging in the a sub 21, since we want to find the 21st term, 4 for a sub 1, and our common difference of 3 in for d. We also put 21 in for n since we're trying to find a sub 21. Okay, now okay, now since 21 minus 1 is 20, we now can use PEMDAS and do 20 times 3, which is 60, and then add the 4 to get a sub 21 equals 64. Okay, now let's find the 12th term of an arithmetic sequence with a sub 1 equals 6 and d equals negative 5. So again, start with your general explicit formula. Okay, now let's plug in a sub n, which is a sub 12 in this case. Okay, a sub 12 because we're finding the 12th term. Plug in a sub 6 for a sub 1, negative 5 for d, and then 12 for n since we're trying to find a sub 12. Now, 12 minus 1 is 11. 11 times negative 5 is going to be negative 55, plus 6, which is going to be a negative 49. So the 12th term here is going to be negative 49. Now, finding the initial term or common difference. Plug the given information into your general explicit formula, and then solve for a sub 1, d, or n. Now I want you to realize when we're finding that initial term or that common difference, or also the nth position, the number of that nth term, you must only have one unknown. If you have two unknowns, you are incorrect in what you're plugging in. You're missing something. There's something else somewhere that you can plug in. Because if you only have one equation, you can only have one unknown in order to be able to solve for it. Okay, so for example here, let's look. A sub 1, find a sub 1 for the sequence. Okay, as soon as it says to find it, it means you don't know it. So go ahead, let's write a sub 1 equals question mark. For the sequence described by a sub 13 equals 16, now that a sub 13 is your a sub n. So n is going to be 13. Okay? And your common difference of d is negative 4. Okay? Now let's write out that explicit formula, plugging this stuff in. Okay? Actually, let's do this. Let's not reinvent the wheel. Okay? So, here we go. We got our explicit formula. A sub n equals a sub 1 times n minus 1 times d. A sub n is going to be a sub 13, which is 16 in this case. Okay, which is 16. And then we are going to take and plug in 13 for n, since that's a sub 13, minus 1 times d, which is negative 4. Now 13 minus 1 is 12. 12 times negative 4 is negative 48. Now, to finish this, to solve for a sub 1, we have to move that negative 48 to the other side. So now, let's add 48. That's what's been done here. You've had to add 48 to both sides. But if you add 48 here, it crosses out. But you got to add 48 on this side of the equal sign. And 16 plus 48, 64. So a sub 1 equals 64. Okay, here's another example. Okay, we're going to find the first term of the arithmetic sequence. So that means we've got to find a sub 1 because we don't know it. So equals question mark. With the sequence, if a sub 15 equals 30, which means n has to be 15, if the common difference of d is 7. Okay, so we're going to plug all that stuff into that explicit formula. Here's your explicit formula. Plugging in, a sub n is going to be 30. A sub 1, we don't know it. N is going to be 15 because we know a sub 15. Minus 1 times d, which is 7. So now, let's take 15 minus 1 is 14. 14 times 7 is going to be 98. Now, since that's a positive 98, we are going to have to take and subtract 98 from both sides of the equal sign. Okay? Now, when we do that, what happens is the 98's crossed out, and we're left with a sub 1 equals. Now, when we take 30 minus 98, that's actually a negative 68. Sorry, negative 68, which is your a sub 1. Okay? Now, here's another example. We're going to find d, or common difference, of this arithmetic sequence. So we need to say that d equals question mark over here. So d equals question mark. That's what we're trying to find. If a sub 15 is 45, which means n is 15, and a sub 1 is 3. Our first term is 3. Okay. So now let's plug that stuff in to our explicit formula. See, it's not really changing much for us, okay? We're going to put in a sub 15, which is 45, equals our first term of 3, plus n, which is 15, because we know a sub 15, minus 1 times d. 15 minus 1 is 14. 14 times d is 14d. Now, what they've done here is they took that 3 and just went ahead and subtracted it from both sides. Now realize they cross out here, left with 14 times d, and 45 minus 3 is 42. Now the only other thing we need to do to get rid of that 14 on that d, since 14 is multiplying d, is to divide by 14. Now 42 divided by 14 is actually 3. So we have a common difference of 3 if our first term is 3 and our 15th term is 45. So that means we got to keep adding 3 to 3 in each successive term until we get to the 15th term. We should get 45. Okay, so now we're going to find the term number n of the arithmetic sequence with a sub n equals 6. Okay, a sub 1 equals negative 34, and d equals 4. So remember, if we're finding the term number, or the position of the nth term, we're going to say n equals question mark. Okay? and we're going to substitute all the rest of that into the explicit formula. Again, all these are the same. The only thing that's different is the exact specifics of how you solve for that unknown variable. Other than that, you're going to plug everything you know into the explicit formula and solve for that one unknown. Okay? Now, a sub n is 6. A sub 1 is negative 34. We don't know n. Minus 1 times d, which is 4. Now, we do have to do the distributive property. 4 times n is 4n. 4 times negative 1 is negative 4. Bring down your negative 34 plus, and your equals 6. Let's combine like terms. Again, remember, they like putting that variable term first. I love doing that. It helps out a lot when you're doing certain things in algebra. Okay, and then negative 34 minus 4 is going to be a negative 38. Okay, now, how do you move that negative 38 to the other side? Well, we're going to add 38. Okay, and if we take and add 38, those cross out, but we got to add 38 to this side, and we get 6 plus 38, which is 44, equals 4n. So now that 4 is multiplying n, so divide by 4, divide by 4. It should be pretty easy to see that 44 divided by 4 is 11. So in this case, the nth term, which is 6, is the 11th term. Okay? Now, let's go back and review real quick our I can statements. Okay? Hopefully by now, after tonight's video, you have learned how to determine the explicit formula for an arithmetic sequence. Okay? And also, you have learned to use that explicit formula to find missing data. Okay? Now, remember, all of this is important because of the reasons shown below. And there's many, 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 many more real-world examples that we're going to look at in class tomorrow after you watch this video. So, thank you guys very much, and you guys have a wonderful night.